Hello dear students, how do you do? Welcome back to this Radio Horizon broadcast ready to run, produced by Rwanda Education Board in partnership with UNICEF and Inspire, Educate and Empower Rwanda. You are with Teacher Jane teaching Geography Senior 6. Dear students, remember in our previous lessons we focused on rocks. Do you remember what a rock is? Alright. A rock is a natural combination of solid mineral particles such as gravel, feldspar, iron oxide, quartz, and other elements which form the solid part of the Earth's outer layer called the Earth's crust. Today we are focusing on minerals. Our objective is that by the end of our lesson, we will be able to differentiate the types of minerals and give relevant examples, discuss their characteristics, but also explain the properties of minerals and factors influencing their value. You can find our lesson from page 161 to 171 of the student book. Hope you enjoy the lesson. Are you ready? Thank you. To start, think of the meaning of a mineral and identify at least two of its characteristics. Think of the meaning of a mineral and identify at least two of its characteristics. Well done. As we have said it, a mineral is a solid, inorganic substance that occurs naturally in the Earth's crust. A mineral deposit is a concentration of naturally occurring solid mineral in or on the Earth's crust. Mineral resources are non-renewable. Yes, mineral resources are non-renewable. It is clear that rocks and minerals are directly connected. Dear students, we have 5 characteristics shared by all minerals. First of all minerals are formed by natural processes. They can form when magma cools, when liquids containing dissolved minerals evaporate, or when particles precipitate from solution. The second characteristic: minerals are inorganic. They are not alive and not made by life processes. Coal, for instance, is made of carbon from living things. Although geologists do not classify coal as a mineral, some people do. Miners, for example, generally classify anything taken from the ground that has the commercial value as a mineral resource. Another common characteristic of minerals is that minerals are solid and have a definite volume and shape. A gas such as air and a liquid such as water aren't minerals because they do not have definite shape. Also, every mineral is an element or a compound with a chemical composition unique to that mineral. The last common characteristic of minerals is that the atoms in a mineral are arranged in a pattern that is repeated over and over again. Dear students, note that fuels like oil are not minerals because, as explained above, they do not meet the following criteria of minerals. Oil is organic. Oil is a liquid. Natural gas is not solid. Fuels don't have a specific chemistry because oil is a mixture of various hydrocarbons with varying chemistry. They don't have internal crystalline structure. However, while petroleum is not a mineral, it can contain mineral particles, as sand, which is not a mineral, often contains quartz, which is a mineral. Now, dear students, using the prior knowledge you have on minerals, this is maybe what you have learned in the previous years or what you see in your area. Identify different types of minerals you know. Yes, identify different types of minerals you know. Alright, the wide varieties of minerals that have been explored by man for general and commercial purposes to satisfy his needs are of two types. We have metallic minerals and non-metallic minerals. Metallic minerals include industrial metallic minerals such as iron ore. When you talk of ore, this means a naturally occurring rock or sediment that contains one or more valuable minerals, typical metals that can be mined, treated, and sold at profit. Yes, we have said that metallic minerals are industrial metallic minerals. Again, metallic minerals include ferroalloy metallic minerals such as manganese, chromium, cobalt, and nickel. Metallic minerals also include precious metallic minerals such as gold, silver, and platinum. The second type of minerals is non-metallic minerals. This category of non-metallic minerals includes salt, tin, potash, asbestos, and sulfur. Rocks or minerals worked because they contain valuable or profitable elements are usually called ore deposits. Minerals are extracted in a mineral ore. For instance, aluminium comes from the ore bauxite. The iron comes from the mineral ore hematite. A mineral can also be called an ore. For example, hematite is a mineral that can also be called an ore. A mineral is an ore if it contains useful substance that can be mined at high profit and be processed and refined into more useful materials. For instance, aluminium can be refined from bauxite and made into the useful products. These products are worth more money than the cost of the mining, so bauxite is an ore. Are we together? Great. Welcome back from this short pause. We have already seen the characteristics of minerals. Dear students, think of two common characteristics of rocks we have highlighted. All right. All minerals are formed by natural processes. All minerals are inorganic. Minerals are solid and have a definite volume and shape. We have said that every mineral is an element or a compound with a chemical composition unique to that mineral. We have also said that the atoms in the mineral are arranged in a pattern that is repeated over and over again. Thank you. Dear students, remember, last time we learned the physical and chemical properties of rocks. We say that physical properties of a rock can be intensive in terms of hardness and softness, or extensive in terms of volume, total mass, and weight. Now, I want to challenge you. Building on physical properties of rock, can you identify the physical properties of minerals? That's great. The most common minerals in the Earth's crust can be often identified in the field based on their basic physical properties such as their form, their hardness, fracture, cleavage, color, streak, density, luster, mass, their taste, their odor, and through magnetism. Now, let us look into details each of the physical properties. The form of minerals, for example, definite geometrical forms called crystals can be recognized in minerals. These are, for example, cubic, circular in forms of needle-shaped, fibrous, reniform like kidney-shaped, and nodular forms. The second physical property of minerals is hardness. The hardness of a mineral can be tested in several ways. Most commonly, minerals are compared to an object of known hardness using a scratch test developed by Friedrich Mohs. Friedrich Mohs has assigned integer numbers to each mineral, where 1 is the softest and 10 is the hardest. For example, the scalar number 1 can be compared to talc as a mineral name, because talc is soft. Quartz is qualified as 7 on the scalar number because it is somehow hard. Quartz is hard. And diamond is scared number 10 because it is too hard compared to quartz. Also, substitutes may be used when the scarce minerals are not available. For example, if a mineral is easily scratched by nail, it is qualified as soft. Some minerals are not so easily scratched by nails. Some minerals can be scratched by a piece, for example, a copper coin. Other minerals can be scratched easily by a knife. We have other minerals that can be scratched by knife with difficulties. Others can be scratched by window glass. Also, window glass is scratched by the mineral. Another physical property of minerals is fracture. Freshly broken surfaces of minerals present characteristic fracture surfaces. Basing in fracture, we have vitreous minerals. The fracture surfaces are curved with a concave or convex form, for example, quartz. We also have even. The fracture surfaces are nearly flat. We talk of uneven when fracture surface is formed of minute elevations and depressions, and most minerals are uneven. Apart from fracture, form, and hardness of minerals, cleavage is also a physical property. Cleavage is how the mineral breaks. Certain minerals split easily along certain planes called cleavage planes. These planes are parallel to certain faces of the mineral crystal or faces of a form in which the mineral may crystallize. We also have color. When a body absorbs all the 7 colors that make up white light, it appears black. And when it reflects all the colors, it appears white. When a body reflects the green vibrations of white light and absorbs the other vibrations, it appears green. Thus, the color of a body depends on the selective reflection and absorption of the different vibrations of white light. Again, we have streak as physical property of minerals. The color of the powder of minerals sometimes differs from the mineral in mass. Different specimens of the same mineral might show variation in colors, yet the streak is fairly constant. Again, we have luster as a physical property. Here, the amount and the type of reflection from the surface of a mineral determine its brightness. There are several types of luster, including metallic, vitreous, resinous, pearly, and silky. Also, we have taste. Some of the minerals which are soluble in water give distinctive taste, but the character is not very useful in identification of minerals because there are only few minerals which are soluble in water. For example, we get saline taste in case of common salt and alkaline in case of soda or potash. Also, odor, magnetism, mass, and density are among the physical properties of minerals. Thank you, friends. The same as physical properties of rocks, we also learned that water, heat, and pressure are among the major agents of chemical properties of rocks. Again, I want you to build on that and think of the chemical properties of minerals because you are looking at minerals. Very good. Some minerals are affected by the variations in temperature and the pressure on the Earth's surface. Others vary in the structure depending on the percentage of water that they lose with the change of the temperature and the pressure. The chemical composition influences the destruction of the rocks and development of new minerals. Chemical properties of minerals are identified from their chemical composition. We refer to two elements that are silicon and oxygen. These are the two most abundant elements in the Earth's crust. They constitute approximately 90% of the crust of the Earth. When we distinguish silicate minerals and non-silicate minerals, silicate minerals are minerals containing silicon and oxygen atoms, usually with one or more other elements. Non-silicate are minerals other than silicate minerals. Are we together? Thank you for your participation. Now, basing on the experience you get from real life, think of the factors influencing the value of minerals. I do agree with you. Minerals provide the material used to make most the things of industrial-based society: roads, cars, computers, fertilizers, and so on. Some minerals have high economic value because of their uses or because they are rare and beautiful. For example, gemstones is a mineral with a distinctive color which makes it expensive. That is why it is used for jewelry. The value of minerals depends on the following various factors. We have like chemical composition, minerals containing rare metals, rare earths, several acids, have high value. Again, rarity of minerals may be classified as due to the quality of the specimen because greatly superior to the average, or the scarcity of the species, variety, or form. Again, commercial value, the form of a mineral, the beauty of a mineral can be classified among the factors influencing its value. When you look at the beauty of a mineral, theoretically, beauty is not a factor in scientific appraisals, as it is an element of art rather than science, but practically, it is one of the most important factors in determining the value of mineral specimens. Also, the size of a mineral may give a high value to that mineral. The mineral might be valued in proportion to their size, so crystals of fine quality increase in value much more than proportionally to their size. Again, the hardness of a mineral. It has slightly mineralogical value, but it contributes much to the commercial value of gems, and it is the chief property of value in the abrasives. Again, associated minerals may give a value to minerals. While the associated minerals do not, as a rule, increase the value of specimen, there are many instances in which they do. This is particularly true if the associates give a clue to genesis of the mineral. Dear students, do you think minerals have an importance in our lives? Yes. We have different manufactured products from minerals. For example, from asbestos, man has developed fire-retarding properties like electrical insulators. From gold, man has developed jewelries, dentistry, and electronics. From limestone, fertilizers are created. From copper, man has made currency, jewelry, plumbing, and electric insulators. Roofing materials are made from slate. Pottery is made from clay. X-ray technology, fireworks, rubber, and glass are made from barium. From manganese, man can develop steel-making products and petroglyphs. Vehicles and building construction materials are made from iron ores. While from uranium, man has developed highly radioactive elements using cancer treatments, X-rays, military weapons, and fuel for the space shuttle. As you see, minerals are important to our lives. As we are concluding our lesson, dear students, can you think of one thing you have learned today? Think of one thing we have learned today. Good. Today, we have learned the 5 characteristics shared by all minerals, including that all minerals are solid. We also learned 2 types of minerals that are metallic and non-metallic. We looked at different physical and chemical properties of minerals and their identification. Then, we concluded on the factors influencing the values of different minerals and the derived manufactured product. Now, as a take-home, you will identify minerals that are extracted in your district and describe their advantages and disadvantages. I repeat, You will identify minerals that are extracted in your district and describe their advantages and disadvantages. With that, as we always say, most natural resources, mineral included, are not renewable. However, human activities have contributed dangerously to consuming these reserves. Dear students, as young generations, it is our responsibility of thinking about the durable exploitation of the resources, thinking of the future generations. Thank you for your participation. Hope we have achieved our objectives. You were with Teacher Jen. Bye.